My name is Dista Aulia Putri. I'm the student of Civil Engineering program in Sultan Agung Islamic University, Indonesia. Today, I'm going to talk about one of the most famous bridges in the world that make a beautiful history on engineering field, the Golden Gate Bridge. In this presentation, I'll share the story behind its design, the challenges faced during construction, and some fun facts that make this bridge so special. So stay tuned! So, here's the structure of my presentation. First, we'll look behind the design and find out what kind of bridge it is. And then I'll share some fun fact about the iconic San Francisco Bridge. After that, I'm going to tell you about the challenges faced by the engineers. And finally, we'll learn how the bridge was built step by step. Let's wrap up this section and see the next stage. Let me start this with quote was written by Joseph B. Strauss, the chief engineer of the bridge. Its titan piers grip ocean floor, its great steel arms link shore with shore. Joseph B. Strauss, the mighty task is done. This quote is a poetic way of describing the strength and beauty of this world-famous suspension bridge after it was completed. Its titan piers grip ocean floor means the giant foundation called piers of the bridge are anchored deep into the ocean bed. The word titan suggests great power and stability, showing how massive and strong the structure is, able to resist the forces of the sea and wind. Its great steel arm link shore with shore describes the bridge, long steel cables, and roadway that stretch across the Golden Gate Strait, connecting San Francisco and Marin County. The bridge arms symbolize how units two lands that were once separated by deep waters. This quote perfectly captures the engineering achievement of the Golden Gate Bridge. It reminds us that building this bridge was not just about connecting two shores but also about overcoming nature's challenges, strong tides, deep waters, and powerful winds. The titan piers represent that foundation work, the essential first step of construction that provided strength and balance. The steel arms represent the suspension cables and roadway, which required precision and teamwork to complete. In short, Joseph B. Strauss used poetic words to celebrate how human skill and determination turned a daring dream into a lasting landmark. So, after understanding this point, let's move on to the next topic. Here, we can see before construction started, the engineers had to decide what kind of bridge they would build. They considered three options: a beam bridge, an arch bridge, and a suspension bridge. In the end, Joseph Strauss chose the suspension bridge because a lot of this type was perfect because it could cover a long distance and stay flexible against strong winds and deep waters in the Golden Gate Strait. After much consideration, Joseph finally decided to use a suspension bridge design because it would be more efficient in terms of both functionally and cost. If a beam bridge were used, ships from the harbor would have difficulty passing through the area, and the construction cost would be extremely high. On the other hand, if an arch bridge were chosen, the ideal arch height would have to be very tall due to the long span of the bridge side. That's all I have to tell you about the story behind the bridge. That's all for this part. Now let's continue to the next one. Fun fact about the Golden Gate Bridge. Let's move on to the next topic. Here are some fun facts about the Pride of San Francisco Bay. The first, its color International Orange. The bridge is painted in bright hue known as International Orange. This wasn't just a show. There were very good engineering and feasibility reasons behind it. The color was chosen because it stands out against the fog and that often rolls in above the bay, making the bridge more visible to ships navigating and strait. It also fits well with the surrounding natural landscape, the hills, the water, and the sky. The architect Irving Morrow believed the orange tone blended nicely with the scenery and yet remained bold. The shade of international orange used here isn't exactly the same one used in aerospace or other industrial uses. It was slightly adapted to meet the specific needs of the bridge, the visibility and weather resistant. So in short, the color is both practically for safety or visibility and aesthetic for blending with the site, which is one of the things that makes the Golden Gate Bridge stand out. The main cables are almost 1 meter in diameter. Here's a deeper dive into that. Each of two main suspension cables has a diameter of 36 and 3/8 inch, which is about 0.92 meters. These cables were made by spinning thousands of individual wires. For example, each main cable contains 27,572 individual wires, each about 0.192 inch in diameter. The process of building those cables was impressive. The wires were pulled between the two towers, looped back and forth until the full cable was built. Why does this matter? Because a cable nearly 1 meter thick show how massive and strong the connection supporting the roadway is. It underscores how serious the engineers were about strength and durability. The third, it was built during the Great Depression, providing jobs for thousands. This fact highlights the social and economic context of the bridge construction. Construction began in 1933 at the height of Great Depression when unemployment in US was around 25%. Because jobs were so scarce, a project like the Golden Gate Bridge offered rare employment opportunities to many local workers. It wasn't just about putting people to work. The bridge project also advanced safety standards for high steel construction, which was significant in the history of construction jobs. So, the bridge is not only an engineering icon, but also a symbol of hope and recovery during a very tough economic time. And the last, designed to withstand strong winds and earthquakes, built for safety and strength. Finally, here are the details behind the statement that the bridge is very strong and safe. Because the bridge spans a sea strait with high winds, deep water, and seismic activity, the engineers incorporated design features to handle wind loads, thermal expansion, loads from traffic, and the possibility of earthquakes. In addition, in later years, the bridge has been seismically retrofitted, so it can resist a strong earthquake. For example, seismic isolation bearings were installed in approach pans to help absorb quake energy rather than transmit it directly to the structure. One site indicates that the bridge can now withstand shaking greater than a magnitude 7.0 earthquake. The further work continues to make it even more resilient. The takeaway, this monumental structure was engineered with expectation of extreme condition, not just normal one. It's designed for both beauty and resilience. Now that we know this, it's time to look at what comes next. The next point I want to highlight is about the Golden Gate Bridge. It's located in San Francisco, California, stretching across the Golden Gate Strait, the narrow entrance where the Pacific Ocean meets San Francisco Bay. This spot is known for its breathtaking views, but it also presented some of the toughest construction challenge engineers have ever faced. The area experienced powerful tides that can reach up to 7 miles per hour, making it dangerous for workers and equipment during the early stage of construction. On top of that, dense fog frequently covers the strait, reducing visibility and making it difficult to work safely, especially when building the tall towers and spinning the main cables high above the water. The salty sea air also posed another problem. It causes corrosion on metal structure. Because of this, the bridge needed to be built using special materials and coating to protect the steel from rust over time. This is one reason why regular maintenance and repainting are still important today. In addition, the location is exposed to strong ocean winds, which can exceed 60 miles per hour. The engineers had to be designed the bridge to remain stable and flexible under such windy conditions, ensuring it could sway safely without damage. To make things even more challenging, the San Andreas Fault, a major earthquake fault line, lies only about 7 miles away. This meant the bridge had to be strong enough to survive earthquakes like the devastating one that hit San Francisco in 1996. Because of all these natural challenges, tides, fog, wind, salt, and earthquake, the Golden Gate Bridge construction required careful planning, advanced engineering, and strong materials. Despite the harsh environment, the bridge has stood tall for nearly a century, proving the skill, creativity, and resilience of the engineers who built it. We've talked about the challenges and see how the engineers solved them. Now, let's see how the historic link between city and sea was actually built. The construction of the Golden Gate Bridge was a remarkable engineering achievement that took place between 1933 and 1937. Despite strong ocean currents, fog, and strong winds, the builders managed to create one of the most iconic bridges in the world. Here's how they did it, step by step. First, before any feasible structure was built, engineers had to prepare the site. The biggest challenge was the deep water and strong tides at the Golden Gate Strait. Workers built large underwater concrete foundations to support the towers. Divers and construction crews used special equipment to anchor the foundation firmly into the seabed. On the San Francisco side, the base was built on solid rock, while the marine side required extra stabilization to handle softer ground. Then, once the foundations were complete, construction of the two massive steel towers began. Each tower stands about 227 meters above the water. These towers were built using large steel sections that were lifted and bolted together piece by piece. The tower served as a main support for the bridge suspension cables. Building them required careful balance and precision, especially under windy and foggy conditions. The next step was to install the suspension cables, the most critical part of the bridge. Workers used a process called spinning to create the main cables by looping thousands of thin steel wires back and forth across the strait. Each main cable contains over 27,000 individual wires, making them extremely strong. These cables were then anchored securely into a large concrete block on the both shores. After the cables were in place, smaller vertical cables called suspenders were attached to support the bridge roadway. The steel roadway sections were then lifted and hung from these suspenders one by one, connecting the two sides until they met in the middle. This step required careful alignment and teamwork to ensure the roadway stayed balanced. Once the main structure was completed, workers added the finishing touches. The road was paved, lighting systems were installed, and the entire bridge was painted in its famous international orange color. This paint not only gives the bridge its iconic look, but also protects the steel from rust and corrosion caused by the salty ocean air. And with that, we've reached the end of this journey across the engineering marvel of San Francisco. But before we finish, I want you to imagine this. Standing on the bridge surrounded by fog, the wind rushing past, and the deep blue water beneath. Every cable, every beam, every bolt, all of it was once just an idea, a dream. Yet through courage, persistence, and human genius, that dream became real. Built in the hardest of times, the Great Depression, the bridge rose not only from steel and concrete, but from hope, the hope of thousands who refused to give up. Today, it still stands tall, glowing in its international orange, reminding us that strength can also be beautiful, and that even against the strongest winds we can stand firm. The Golden Gate Bridge is not just a path between two lands, it is a symbol of what humanity can build when we dare to believe. Thank you. If you guys have any question, you can write down below.